Hi again. We're going to go over determining just the vertical asymptotes today. We saw in the last video, the overview video, that asymptotes are one characteristic of a rational function. So how do you go about determining vertical asymptotes? Well, what we have to do is make sure that we have the numerator and the denominator factored and look to see, can I do any canceling? And then if I can't do any canceling, I'll set each piece of the denominator equal to 0 and solve. And those are going to be the vertical lines, the equations for the vertical lines for our vertical asymptotes. So let's look at some examples. F of x equals x plus 1 over 2x minus 1 times x plus 3. Now we know this is a rational function because it's set up to be a fraction with x in the denominator. So that means we are going to have a hyperbola when we graph. Hyperbolas have vertical asymptotes. So that's the first thing we're going to do when we want to graph these is find our vertical asymptotes. So notice that both the numerator and the denominator are in factored form. So I don't need to do any factoring. So we're going to set the denominator equal to 0 and solve for x. So each piece gets set equal to 0. And in one case, x equals a half. And in another case, x equals -3. So here in the corner of the screen, the green line and the orange line represent those two vertical asymptotes. Again, those are like do not cross lines for our graph. Let's look at another example. F of x equals 2x plus 1 over x minus 3. Find the vertical asymptotes. So, are our numerator and denominator factored? Yes, they are. They can't cancel, so we don't have to worry about any canceling. We're going to set the denominator equal to 0 and solve. That one's pretty easy. So we have a vertical asymptote at x equals 3. And here's a picture of our graph showing our vertical asymptote, our do not cross line. Here's another example. So I have x squared minus 25 over x plus 1 and x minus 5. Now in this case, the numerator is not factored, but the denominator is. So I factor the numerator, and I notice that I have two matching factors. It turns out that when you have two matching factors, you don't get a vertical asymptote out of our x minus 5. We get something else. What actually will happen algebraically is those two terms will cancel, but they don't just disappear forever. We still have to account for them having been there at one point. And what happens is we get what's called a hole at x equals 5. If I set x minus 5 equal to 0 and solve, I'll get x equals 5. But I don't get a vertical asymptote there. It's called a hole. I do get a vertical asymptote at x equals -1. So I've used a graphing calculator program to show you my vertical asymptote here in green, x equals -1. And over here, when x equals 5, I have the graph. This is just the graph of a rational function, a hyperbola, but I have a missing part of my graph here. That's what is meant by a hole. If you look over here on our xy chart, when x is 5, y shows an error. That's because I get 0 in the denominator. So even though x minus 5 cancels, you still need to account for it being there, at least at the beginning. And this is how we do that. There's a hole there instead of a vertical asymptote.